Lesson 8-3, Elimination using addition and subtraction. And in this lesson, you learn to solve systems of equations by using the elimination method with addition or subtraction. Why is it important? Because you can use systems of equations to solve problems involving entertainment and testing. Let's take a look at this real-world application. Cartoons are animated using a computer process that makes the action flow smoothly and seem lifelike. On a Saturday afternoon, the Johnson and Oliveira families decided to go to see an animated movie together. Johnson family, okay, two adults and four children can afford to spend $30 from their entertainment budget this weekend for the movie tickets, while the Oliveira family, two adults and two children, can afford to spend $21.50. Different theaters around town charge different amounts for adult and child tickets. What price can the Johnsons and Oliveiras afford to pay for each adult and each child? Okay, so let's answer this question. Okay, uh, we need to represent A, okay, B the ticket price for one adult, and C represent the ticket price for one child. Okay, so the information in this problem can be represented by the following systems of equations. Okay, using the Oliveira family and what's the other family? Using the Oliveira family and the Johnson family. Okay, so if we do that and let A represent the child of an adult ticket and C represent the child of a of a child ticket, okay, we have two equations. Equation number one, 2a plus 4c equals 30, because you have two adults and four children, okay, for the Johnsons. And for the Olivier family, 2a plus 2c equals $21.50, because they can only afford to spend $21.50 for the Olivier family and $30 for the Johnson family. Okay, so from the graph, okay, if we graph these two equations, like assuming that you know how to graph equations, okay, 2a plus 4c equals 30 will be this graph right over here. Okay, again, using our methods for graphing by using a table, using intercepts, using point slope form, or using y equals mx plus b. So all of those can be used to graph these two equations. So if you notice, this becomes now the graph of 2a plus 2c equals 2150, which is the Olivier family's budget. Okay, so from the graph at the right, an estimated solution would be $7, 7 and 4. Okay, if you look at our graph, that point is approximately $7 and $4. Okay, so to get an exact solution, okay, for this one, to get an exact solution, we need to be able to solve it algebraically. And you can solve this equation by first solving either of the equations for A and C, and then using substitution. Okay, we talked about in the past that the graphing method is a good method, but it's quite inaccurate to find an exact solution. Then we need to use the other methods in solving systems of equations. And one of these methods, okay, from what we learned in the last lesson, is called the substitution method. Okay, now we can use the substitution method to solve this system of equations, but there's another one. A simpler method of solution is to subtract one equation from the other, since the coefficients of the variables are variable a are the same, and this is called the elimination method, because the subtraction eliminates one of the variables. First, write the equations column form and then subtract. Okay, so we write 2a plus 4c equals 30, okay, minus 2a plus 2c equals 21.5. Now, okay, when you talk about the elimination method, the reason why it's called the elimination method, because you want to eliminate one variable so that you are left with only one variable for you to solve. So if we do this, if we subtract 2a plus 2c equals 21.5 from 2a plus 4c equals 30, you need to remember that when you're subtracting something like this, okay, there should be a parentheses. So in that case, you're basically multiplying by negative 1. So we're basically multiplying by negative 1. We end up with 2a plus 4c equals 30. Now look what happens. The negative 1, okay, has been distributed to 2a. That's why you have negative 2a. Distributed to 2c. That's the reason why you have negative 2c. And it's been distributed to 21.5. That's why you have negative 21.5. And after you distribute the negative 1, you simply add, okay? And if you notice, the 2a, okay, is eliminated, or the variable a is eliminated, and you end up with 2c equals 8.5, which is the difference between 30 minus 21.5. And from there, you simply solve for c by dividing both sides by 2, and you end up with 4.25. Now we found the value for c, okay? We now substitute the value for c to any of our original equations. We can either substitute it to 2a plus 4c equals 30, or 2a plus 2c equals 21.5. Okay, so substitute 4.25 in either equation, and in this case we will use 2a plus 2c equals 21.5. So we will use equation 2. Remember what I told you about systems equation. It would be very useful for you to name your equations. Okay, so we substitute 4.25 to equation number 2, and from there we have 2a plus 2 times 4.25, which is the value of c, equals 21.5, and we simply solve for a. Okay, simplify 2 times 4.25 becomes 8.25. Subtract that to both sides, you end up with 2a equals 13, and divide both sides by 2, you end up with 6.25. Okay, so that means the value of a will be 6.25. The value of c will be 4.25. Okay, so meaning that the adult ticket is around $6.50, and the child ticket is $4.25. Now, how do we know if 6.5 and 4.25 is a solution to our system? Then all we need to do is check it. First equation, 2a plus 4c equals 30. Substitute 6.5 and 4.25 to a and c, and then we end up with 30 equals 30. This checks out for the first equation. And for our second equation, we substitute the same thing, 6.25 for a and 4.25 for c, and we still end up with 21.5, a true statement. Therefore, okay, the ordered pair 6.25 and 4.25 checks out. Okay, and if you notice, okay, when we graphed our system, we estimate the solution to be $7 and $4. Close enough, 6.5 and 4.25. Okay, so the solution of this system of equations is 6.5, 4.25. Thus Johnson's and Oliveira's could look for a theater that charges $6.50 for each adult and $4.25 for each child. Let's take a look at example number 1. In some systems of equations, the coefficients of terms of containing the same variable are additive inverses. For these systems, the elimination method can be applied by adding the equations. So let's take a look at example number 1 and see how this works. Okay, use elimination to solve systems of equations. Again, you have equation 1, and you have equation 2 right there. Okay, so look at this carefully. Okay, since the coefficients, okay, of y, okay, are negative 2 and 2, they're called additive inverses, meaning if you add them, they become 0. So you can solve the system by adding equations. So what do? We get 3x minus 2y equals 4, which is the first one. write the equations in column form, and then we simply add them. Notice that the variable y in this case is eliminated, so this variable y becomes 0 and is eliminated, and you now have 7x equals 14. And then we simply solve for x, that becomes x equals 2. Now get 2 and substitute it back to either equation 1 or equation 2. Okay, so we substitute x in either equation to find the value of y. In this case, we substitute it to 3x minus y minus 2y equals 4. So if x is equal to 2, this becomes now 3 times 2 minus 2y equals 4. This becomes 6 minus 2y equals 4, and we solve for y. We subtract 6 to both sides, you end up with negative 2y equals negative 2, and we divide both sides by negative 2, end up with y equals 1. So the solution for this system, or of this system, is 2, 1. Okay? So take a look at the next example. Use subtraction this time to solve a system of two linear equations whenever one of the variables has the same coefficient in both equations. Now before we solve equation number 2, let me say the secret word. The secret word is patriots. The secret word is patriots. Okay? So example number 2, the sum of two numbers is 18. The sum of the greater number and twice the smaller number is 25. Find the numbers. So first things first, we have a let statement. So let x be the greater number and let y be the lesser number. Since the sum of the numbers is 8, one equation is x plus y equals 18. Simple enough. And then look at sentence number 2. The sum of the greater number and twice the smaller number is 25. We now have the equation x plus 2y, the sum of the greater number, which is x, and twice the smaller number, which is y, is equal to 25. And then we equate them. X plus y equals 18, x plus 2y equals 25. And if you notice, we simply subtract them, because when we subtract them, we eliminate x, end up with y. Now another thing that I told you about when you're subtracting, remember that there is a parenthesis here. So when you are subtracting, okay, you're basically distributing the negative 1. Okay, so this actually becomes, if I'm going to rewrite this, this becomes x plus y equals 18. That does not change. After you distribute the negative 1, this becomes negative x minus 2y equals negative 25. Okay, now if you follow that, okay, you end up with y minus 2y will give you negative y. 18 minus 25 right here will give you negative 25. So if you follow this, this becomes negative y equals negative 7, exactly what you have there. Okay, and multiply both sides by negative 1, end up with y equals 7. Okay, so let me erase this because there's something written here which I would like you to know, and this is it. Okay, since the coefficients of the x terms are the same, we use the elimination by subtraction. Now we found the value of y. To be able to find x, okay, find x by substituting y in one of the equations, and in this case we use the simpler equation, which is equation number 1, x plus y equals 18. So if you use x plus y equals 18 and substitute the value for y, we end up with x plus 7 equals 18, and then we simply subtract 7 to both sides. We end up with x equals 11. So the solution, 11, 7. Okay, the solution is 11, 7, which means that the numbers 7 and 11, okay, are the ones that we are looking for. And if you want to check your answer, you simply go back to the words of the problem. Okay, the sum of two numbers is 18. 7 plus 11 is 18. That checks out. The sum of the greater number, which is 11, and twice the smaller number, okay, 2 times 14, 2 times 7 is 14, plus 11 should equal 25. And it checks out. Okay, and that's how you check it, by going back to the words of the problem. Let's take a look at example number 3. So another word problem, Lena is preparing to take the Scholastic Assessment Test, SAT. She has been taking practice tests for the year and her scores are steadily improving. She usually scores about 150 points higher on the math test than on the verbal test. She needs a combined score of 1,270 to get into a college she has chosen. If she assumes that she will have a 150-point difference between the two sets, how high does she need to score on each part? Okay, so again, like any good word problem, is a good let statement. So let M represent Lena's math score and let B represent Lena's verbal score. Okay, and since the sum of her scores is 1,270, one equation is logically M plus V equals 1,270. And since the difference of her scores is 150, another equation we can put is that M minus V, the difference of her scores, is equal to 150. Now we can use the elimination method to solve this problem. Okay, and if you notice, okay, V and negative V are additive inverses, so we simply use addition to eliminate V, and then we end up with m plus m equals 1,420. We simply use addition, and then we solve for m, divide both sides by 2, end up with m equals 710. Now that we know that m is equal to 710, we find v by substituting 710 in one of the equations. It doesn't matter which one. In this case, we will use the equation m plus v equals 1,270. Get the value of m, substitute it to our m, end up with 710 plus v equals 1,270. And solve for v by subtracting 710 to both sides, end up with v equals 560. So your ordered pair would be 710 and 560, which means that Lena must score 710 in math and 560 on the verbal portion of the SAT. Okay? And we've come to the end of this lesson. Thank you for watching.